So to welcome to today's session, and I will be introducing another topic which is broadly categorized as the calculus. But today is so calculus is divided into two. The first one is differentiation, and the second one is integration. So we shall have two topics in calculus. And as I've indicated, the first one is differentiation, and the second one is integration. And during this session, I am going to go through differentiation in totality. So allow me to erase this, and without much ado, go straight away to differentiation. Now, to begin with, I want to remind you something that we did in, or you have done in coordinates, not coordinates, but graphical methods. So in graphical methods, we did cubic functions, and also in quadratic equational expressions, we did quadratic functions. And in this case, you must be aware of how to draw a curve by now. So if you have such a curve, you might be required to recall how to find the gradient of that curve at a given point, and that we called instantaneous rate of change, or rate of change at an instant, and that instant in this case is, say, this point. That basically means getting the gradient of a curve at a given point. So if I am given this point, x, then I'm required, let's say at x is equals to 3. I am required to find the gradient of the curve at the point x is equals to 3. So, and when you locate that, that is what we get. And you recall that we were supposed to get a gradient, or we get the gradient of a curve at a given point by drawing a tangent to the curve at that particular point. So you draw the tangent to the curve, and remember, when drawing a tangent should only touch the curve at only one point. So only one tangent can be drawn from any given point of a curve, and in this case, we have drawn the curve as such. One thing before we even proceed with this, you need to remember that the gradient of a curve is different throughout the curve. So you expect that the gradient at this point is different from the gradient of the curve at this point, different from the gradient of the curve at this point, and at this point. And at any given point, you get the gradient of the curve by drawing a tangent to the curve. So like I have done in this case, after drawing the tangent, recall that the gradient of the curve is a straight line. I mean, the tangent of a curve is a straight line. And how do we get a gradient of a straight line? Recall, you must have done something like that, whereby in this case we have change in y, then along this line we have change in x. And so you get a gradient is equals to change in y over change in x. So you will do the same thing if you want to do the gradient of the curve. If you want to get a gradient at this point, you'll still draw a tangent to the curve at that point, then find the gradient. If it's this point, you draw another tangent, then change in y over change in x, etc, etc. So anywhere along the curve, to get the gradient of the curve, we start by drawing a tangent to the curve. A tangent to the curve. With the tangent to the curve, you find the gradient of the tangent. So at this point, you should notice one thing, that we are finding the gradient of this line, the tangent. And after getting the gradient of the tangent, that becomes the gradient of the curve. So what are we saying? We are basically saying that the gradient of a tangent is equivalent to the gradient of the curve at that point where we have drawn the tangent. However, you don't worry about that because we'll still discuss that one in details shortly. But for now, that is what you need to remember. Now, in this topic, we shall be doing the same thing, getting the gradient of a curve, getting the gradient of a curve. However, no, in this case, we will not use this approach of drawing a tangent to the curve. So I'm going to introduce another method that you can use to get the gradient of a curve at a given point. And that is the first thing that we want to discuss. So let's say you have a function y is equals to x to the power 4. So that is the equation of a curve. That is the equation of a curve. So let me write the first subtopic, call that derivative. Or gradient function, which can also be called the derived function. All these mean one and the same thing: derivative, gradient function, or the derived function. They all refer to one and the same thing. So what is this that you're calling derivative, gradient function, and the derived function? So like I was saying, given that y is equals to x to the power 4, how do you get the derivative of this function? And notice that we are saying the derivative, the other name is the gradient function. How do you find the derivative of this function? So the derivative of this function is obtained in a process called differentiation. So to get the gradient function of this curve, or the derivative or the derived function of this curve, we carry out a process called differentiation. Now, how do we carry out differentiation? So differentiation is given by dy over dx. Now, this is read as the derivative of y with respect to x. The derivative of y with respect to x is equals to, now how do we differentiate? Step number 1, you take the power, so multiply the function with the power, so 4x to power 4 minus 1. So you take the power, multiply by the coefficient of x, then the power, subtract 1 to get 4x to the power 3. Remember this function from your knowledge in graphical methods and also cubic functions is called a polynomial. Not cubic functions, but a binomial expansion. This is a polynomial. It has several unknowns, y and x, polynomial, and has several terms. So in this case, you just take the power, multiply by 4, multiply by the coefficient of x, which in this case is 1. So we go to a 4x. Now subtract 1 from the power to get 4x cubed. And this is called the derivative of the function, or the gradient function, or the derived function. Maybe I can introduce another one, another example. 2y is equals to 5x squared. So I've said step number 1, to get the derived function or the gradient function dy over dx, we're going to take the power multiplied by the coefficient of x, and notice that in this case the coefficient of x is 5. So we're going to have 2 times 5, the coefficient of x, now x to power 2, then subtract 1 from the power, minus 1. So the derived function will be 10x to power 2 minus 1 is 1, so it's basically 10x. That is going to be 10x. Now let us see now polynomials with several terms. Here we only have one. Y is equals to x power 5, y is equals to 5x power 2. So we look at this. It will find the derivative of s is equals to 2t cubed minus 3t squared plus 4t. So in this case, the previous one was y and x, and that is when we're talking about dy over dx. But in this case, we have s and t. So to find the derivative, we're going to talk about ds over dt. The derivative of s with respect to t. That is how this is read. The derivative of s with respect to t. And you must write it this way to indicate that you are carrying out the process of differentiation. Now let's see. So it says step number 1, the power multiplied by the coefficient, in this case of t. So 3 times 2 to get 6t. Now the power subtract 1. So 3 minus 1 to get 2. Minus, again the power multiplied by the coefficient. So 2 times 3 to get 6t. 2 minus 1 is 1. So that is basically 6t plus the power is 1. So 1 times 4, that is still 4. T, it was to power 1. So 1 minus 1 is 0. So we have 4t, t to power 0 is basically 1. So in that case, we're going to be left with, so t to power 0 is 1. So any number to power 0 is 1. So we're left with 6t to power 2 minus 6t plus, we're saying that t to power 1 minus 1 is 0. So t to power 0 is 1. So 4 times 1 is 1. So plus 4 times 1 is 4. So you get 4. So let us look at another one. We can look at another example. We have a is equals to v squared minus 2v plus 10. So you're supposed to find the derivative or the derived function or the gradient function. So in this case, again, same process. D, but again not dy, but in this case we have a and v. So it's dA over dv is equals to the power multiplied by the coefficient. So the coefficient here is 1. So we have 2 times 1, 2. V to power 2 minus 1 is 1. So that is 2v minus the power here is 1. So 1 times 2 is 2. Then v, the power here we're saying is 1. So 1 minus 1 is 0. So remember, we've said any number to power 0 is 1. So we're going to have v to power 0, which is 1. So this one can be changed to 1. And the last part, when you're given a constant, 10. Differentiate 10. When you differentiate 10, the answer is 0. So in this case, when you told differentiate 10, the answer is 0. So in this case, we are left with 2v minus 2. That is the answer. Let me emphasize this. When you're told that, say, x is equals to 2, differentiate. So when you differentiate this, the answer is 0. Differentiate 2, 3, 4, 5, etc. Any constant. When you differentiate a constant, the answer is 0. And that is why we just forget about this 10. Yeah? Because when you differentiate 10, the answer is going to be 0. The answer is going to be 0. And that is what we need to know in that case. So, if I am given the equation y is equals to x cubed plus 2x plus 1 at the points 1, 4. At the point 1, 4. So, in this case, you're told to find the gradient of the curve. In fact, let me indicate that. Find the gradient of the curve y is equals to x cubed plus 2x plus 1 at 1, 4. Now, this is the climax of the introduction of this topic, whereby we are going to see how we're getting the gradient of the curve at a given point. Notice that previously we've just done the process of differentiation. We've just familiarized ourselves with how to differentiate the function of a curve. Now, in this case, we want to see how do you find a gradient. Remember, when you're given the function of a curve, you can get the gradient function, the equation of the gradient, by differentiating the curve. So we are going to have dy over dx is equals to, so differentiate x cubed. So you, with the power multiplied by the coefficient, so 3x. Now the power subtract 1, so 3 minus 1 to get 2 plus the power is 1, so it's 1 times 2, 2x to power, this was 1. So 1 minus 1, 0. X to power 0 is 1. So in that case, we have 2 times 1. So we're left with 2. And again, the last part is 1. So we'll differentiate 1. I've just said when you differentiate a constant, the answer is 0. So this is going to be 0. So the gradient function is here. Now, if this is the gradient function, or what is called the derived function or the derivative, and we are told to find the gradient of the curve at this point in coordinate form or in coordinates. When you're given 1, 4, that is basically the form xy, whereby 1 is in place of x and 4 is in place of y. And this means, therefore, that the value of x is equals to 1. And look at it this way. We have the gradient function 3x squared plus 2. But, so the gradient function is 3x squared plus 2. But, x is equals to 1. That means we can therefore get the gradient. That is 3 into 1 squared plus 2. So you have 3 plus 2, which is equivalent to 5. And that is the gradient of the curve. And that is basically how we get the gradient of a curve at a given point. So start by differentiating to get the gradient function. Notice that we are given the value of x at that point. So at the point 1, 4, which means the value of x is 1. So in place of x in our gradient function, you replace with 1. So 3 into 1 squared plus 2. 1 squared is 1, 3 times 1 is 3, 3 plus 2, you get 5. And that is the gradient of the curve at that point, the point 1, 4. So you should be able to internalize that. That should be very easy for all of us. So having understood that, I will now introduce something else. So the next subtopic, so equations of tangents and normal to a curve. So this is something that you already know. Recall that while we were introducing this topic, I remember we had set a curve and we found the gradient of the curve at this particular point where x was 3 by drawing a tangent, so that we can get change in y over change in x. So in this case, you notice that by getting the gradient of the tangent, we have found the gradient of the curve. So if you have the gradient of the curve, that means you have the gradient of the tangent. I repeat, we started by getting the gradient of the tangent. And by getting the gradient of the tangent, that meant that we already have the gradient of the curve by changing y over change in x. But in this case, we have learned how to get the gradient of a curve using differentiation. And that means, therefore, the general rule, therefore, in this case,